Hello, guys and girls. Good morning.
Hello, everybody. Good morning.
Good morning, teacher.
Good morning.
So before we start today's session, I want to review with you some keynotes on the financial statement. As I think there are some issues, not issues, as I think there are some things that maybe we will need. Maybe you guys are wondering what to do, or maybe you just haven't noticed yet, and they might come and be an issue for you when you do your homework. As remember, for you to get your cash flow your cash flows for the months correctly, you need to have your income statement actually correctly formed. So let me go ahead. Okay. Let me check if this one's the correct one. Station expenses. Okay. So I'm going to show you the cash flow because that you have to build. But I will review with you the income statement, all right? And I hope that you have some questions regarding the income statement. You can ask me now. Okay. So first off, the first thing we need to check is that how are we going to be registering the expenses? Now remember, these are monthly expenses. So the expenses that you find in the case scenario that said that are fixed, that is there is a fixed amount of money being taken out of the company each month. You need to put as fixed at the first month and make sure that you are actually using monthly amounts. For example, here at the union fee, it's 3,000 pesos a year. So you will divide 3,000 by 12, and that's the amount you are supposed to put here, to write down here at the monthly expense. So that's the first thing that I will ask you to check, and that is that you are taking the fixed expense at the first month as monthly expenses. Be careful and not to just to take the amount at face value. Check very carefully that you are actually taking the monthly amount. Second thing is that you have variable expenses. These are just really simple to calculate. You just put the percentage and then you just multiply it by the sales. So that should be actually pretty straightforward. Nothing hard there. And other keynote I want you to notice is that the increment on inflation comes at the change of the year, not at the change of the month, all right? Because inflation is a yearly increase. So we're gonna just increase at the beginning of the year, and then we're just gonna leave like that the rest of the year. And that only happens with the fixed expenses, you see? So make sure that if you are adding, not that if you are, because you are supposed to add inflation. Make sure that when you add inflation, you are adding it at the change of the beginning of the year. That is a January 2007 in the case, right? So that will be another thing. And last thing, and not less important, is depreciation. So depreciation for you guys, well, I seen, I know that some of you have some questions how to register depreciation, and there are some issues with depreciation registering regarding financial presentation norms. We just not want to take that into consideration. I just want you guys to add up the assets and divide them by 120 at the month of buy. That means that you will do that the month that you buy You will do that at the month that you buy the assets. So you just will add up these three and you just divide it by 120. All right. And check out that you are supposed to have three different values of depreciation. One at the beginning, and this one lasts until July 2006. Then, I'm sorry, no, until August 2006. And then it changes, right, at the first increment on assets, which is your first investment on CapEx. And again, it changes at the second increment on assets. And then it stays the same, 28,000. Okay, and check that this one doesn't change between periods, right? The precision remains the same even though you change year. That is not affected by inflation. And can someone tell me why the precision is not affected by inflation? It's a question for the group.
Because you have already paid for your machine or building or whatever.
That's 100% correct, Andrea, because you already paid for it. It is not a cash outflow. That's the same reason why you add it up at your cash flow statement. Okay, so those are the three things that I see you guys been asking me. Again, this is not a class about financial statements. That is why I'm giving you the answer. But anyway, if you still have questions, you can ask for a private session, tutoring session for me or with Felipe, and we can help you out. So that would be it. Do you have any other question regarding your financial statements? Remember, you need to do this
Teacher,
for the.
in which month do the assets change?
Which month do the assets change? The assets change at the month of September and October 2006. They increase by 100 each month.
Teacher, do you think that we can review real quick the cash flow and where do the CapEx affect the values?
Well, I cannot, well, that is actually something I will be grading on your homework. So I cannot show you the answer for that. What we can do is reviewing how CapEx affects the cash flow as a concept, all right? So you have three different cash flows inside your cash flow statement. You have operating activities, you have investing activities, and you have financing activities, all right? And CapEx affects the cash flow at the investing activities. You have to subtract it from the investing activities. And why do you have to subtract it from the investing activities, Frida?
Because it is part of the, I think it's furniture and restaurant equipment.
Yeah, it's to buy restaurant equipment. That's correct. But why do we subtract it from the cash flow?
Because an increase in assets, it means decrease on the cash.
Exactly. That's exactly the reason. Yes, thank you. Who answered? Because your name didn't light up.
Me, Elric.
Eric, thank you, Eric. Yeah, that's exactly correct. The reason why we subtract it from the investing activities because investing in the cash flow has to do with asset increase or decrease. And an increase in assets means that you bought assets, and now buying assets means that you actually pay for them. So we need to subtract it from the cash flow.
Teacher, I'm sorry. Could you repeat us how to calculate the depreciation?
To what? Show you the depreciation? Yeah.
Yes.
Just you're watching my screen, right? Because I don't.
Yes.
Yeah. Okay. So.
We are watching.
Okay, so you just have to add up all the assets of the month, and then you just have to divide it by 120. All right, and we are going to
Okay.
apply at the same month that you are doing the increase on assets. Now again, in future accounting courses, you might be you actually you will be reviewing when do you apply depreciation, and it can be a month after. We are not going to go into that because we will have to review the NIF, and just it's not a class about NIF, so don't worry about it. So just put it on the same month as the increase, okay?
And what do we have to divide it into 120?
Well, you have to divide it to 120. Why? Actually, why do we have to divide it, Citlali, by 120? You tell me, what is the formula for a straight line depreciation?
It was for the lifetime of the asset.
Lifetime of the asset, exactly. That's correct. What is the lifetime of the assets we are assuming here?
I don't know if it was mentioned in the case.
But here, which
okay.
what is here? Why am I using 120? If it is a lifetime and I need the monthly value. Please, someone help us. Don't leave Citrali and me wondering.
Because it was
Maybe it's 10 years?
It's 10 years, exactly, Citrali. Thank you. Thank you too, Andrea Castresana. That's exactly the reason, because it is 10 years, and I'm pretty sure Andrea was going to say the same. It is 10 years of useful life of the asset. And the depreciation in straight line, the formula says that you have to subtract the salvage value from the purchasing value and then divide by the usage value of the asset. Now, we are not subtracting anything.
Sorry, Christopher, only to say something obvious. It is not only 10 years, it is 120 months. Okay, so that is why we are dividing between 100.
Oh, yes, because it's 10 years, 12 months each year. Well, 10 times 12 is 120. Because I need the monthly depreciation.
Okay.
That was the question. Actually, Citlali, I'm sorry, maybe I was just moving around and you just were wondering why it's 120. Well, it's, I mean, not why because of the formula, but why 120 and not 12? Because it's 12 years. I mean, not 10 because it's 10 years. Well, the reason is because you multiply 12 months times 10 years and it's 120. Anyway, so do you guys have any other questions? Citlali, was that clear now?
Yes, thank you.
Great. So regarding your income statement, you guys have any other questions?
Teacher, I just don't know why I have a small difference in decimals in my income statements.
Well, don't worry about the decimals. Actually, you know what I'm going to do? I'm going to share with you well, maybe the reason why it's because, I don't know, maybe I'm using less decimals that you guys are doing. Other of your classmates told me the same, but I mean, for me it's working. I don't know why. Maybe the Excel spreadsheet I share with you, because I tested it as values and not as formulas as I have it here. Maybe that it's making the difference. Don't worry about the decimals. I mean, if you have a small difference with decimals, it will not affect the cash flow. And remember, the actually important one, and I want you to check that out, because if you don't do it like that, you may get an incorrect number. This is just for the financial statement, like for the cash flow statement, like from the 99 to the 112. All right. Your cash flow from the period is actually this one: 42,000, 52,000, 63,000, 59,000, 55,000. All right. I'm showing you the answer now, guys. I mean, if you are really clever, maybe you are changing your statement right now. So that's actually the ones we are going to be working with. And why am I telling you this? Because if you are doing this that I'm doing here to check if they are correct, and then you apply the net present value, internal rate of return, and whatever else in indicator we're going to be reviewing today, at this value here, you will be incorrect. Okay, from here to here is just for the cash flow statement, and it is for presentation. The cash generated in the period is the one that you actually need to be taking into consideration when you do the analysis we're going to be doing today. And maybe on Friday also. I mean, I hope today's class is enough. Anyway, that's
Teacher?
really, really important keynote. So did you guys actually?
Teacher, how do we calculate the line of accumulated depreciation and amortization?
This one here?
Yes.
Well, that's a fixed value for you. So don't worry about the balance sheet. At the balance sheet, I just want you to check the assets. And if you compare it with the cash, it's supposed to be the same number as the addition as did with the other one. But actually that is not.
It's not important because I have different numbers on some of the
on this one?
Of the months.
You don't have these numbers on accumulated depreciation?
It changes when my assets change.
Maybe right? I gave you the previous balance sheet when accumulated depreciation had only accumulated change. Okay, don't worry. I will upload again the balance sheet so you guys can check it back. And actually, it's correct. I will do that because that's the way you can actually check if your cash flow statement is right. Because yeah, I mean, now that I think about it, for you to check that your cash flow statement is right, you need to have 0 here. I mean, if it is different by cents, just see that I have it formulated here because I built this one. So maybe that's why it's not giving you like by the cent, but it should be like pretty close. Like maybe here and here, the difference should be minimal. 5-6 cents, something like that. But more than that, it's actually something different with the financial statements. But I will share with you back again the cash flow, the balance sheet, so you can review your cash flow, okay? And again, when you review your cash flow, remember that you are not doing the calculations of time value of money with this amount here. I'm gonna put it in red. Not this one. You are actually using this one. And why are we using this one? Well, because we are evaluating the ability of the company to generate cash flows. Remember, the primary objective from the financial perspective of the company is to generate cash flow. So all the analysis we're going to be making are going to be regarding cash flow, generation of cash flow. So I will just write that down that I need to share with you again the balance sheet in case you have different numbers. Share.
Actually, I saw yes, there are different numbers in the balance sheet, but is there any chance for us to upload the work on Thursday so we can make the changes that we have to make, and then that would check our answers?
Thursday, yeah, I will change. Actually, I will change the date of the homework because I was hoping to finish this on Friday. We didn't, so I will change it to Thursday. Yeah, because I think it's for tomorrow, right?
Yes.
So I will give you an extra day for you guys to deliver the homework, which I think it's fair because we haven't reviewed what you are actually need to do, like the net present value and that's actually an important thing about the course. Again, I'm showing you the answer for this because it is not a financial statement class. It's not an accounting class, but you are, well, you are supposed to build this. Actually, you are supposed to build this just out of previous knowledge. So, well, anyway, do you have any other questions regarding the financial statements, guys and girls?
No.
No?
No, teacher.
Okay, anyway, if you still have a question, this doesn't mean that you cannot ask me for a session, for tutoring, for a review session. I can do that anyway. I just saw that many of you had questions and I thought, well, maybe it wasn't so clear. So I'm gonna use some of the time on Monday to like quick review of the answer of the income statement. But if you have questions, it doesn't mean that you cannot, I mean, not just because I reviewed this with you now, it doesn't mean that you cannot ask me later for a session, okay? So last session we went ahead and we reviewed the capital budgeting. We had an introduction to capital budgeting and some really important terminology, and then we dive into net present value. And I was telling you guys what net present value was. I was explaining you the time change of money, all of that, and then we were talking about a really important thing about net present value, which is actually the discount rate. This is here. I mean, if you take this, there are two things inside the formula. One is the cash flow, and this one comes from the financial statements. So this one you have it completely figured out by now. And the other one is the rate. And the difference between rate and cash flows, I mean, that your ability to determine those two is actually one of the primary factors for you when you are doing the analysis. That means that if you get the cash flows wrong, all the analysis is wrong. And if you get the rate wrong, all the analysis is wrong. So you need to be really careful about those two. Cash flows, we already reviewed it. They come from the financial statements. You already know how to do that. You will be changing that in your solution in case you had it wrong. Now about the rate, I told you the three types of different discount rates that you have when you are doing the net present value. And the last one we were checking was weighted average cost of capital. And I added this one here because I thought I was reviewing this during the weekend and I thought maybe it wasn't completely clear. I just want you to think of cost of capital, weighted average cost of capital as a little bit more complex and complete cost of capital. Okay, weighted average is that you take different rates inside your discount rate because you are trying to mix a little bit of the risk on the cost of the investment. And we were reviewing weighted average cost of capital, and I think we did it too fast because I was actually, after the class ended, I was reviewing the answer. And it was wrong. I mean, we just rushed through that. So we're gonna review it again, okay, guys? So weighted average cost of capital is a weighted average. It's really simple. It's just, in Spanish, we call it prorrateo. It's a weighted average. That is, you take into consideration the percentage composition of a whole, and then you just add it. You just add it up, all right? It's just, you have 100%, like a summatory of something, and then you have 100% divided by percentages, and then that multiplied by the amount you want to add, and that gives you the weighted average. It's a pretty simple. I mean, it's pretty straightforward formula. The only main difference is this one, and this one is called tax shield, all right? And what is the tax shield? Well, taxes are a deduction in your cash flow. I mean, a deduction in your tax bill. Taxes, I'm sorry. Interests are a deduction on your tax bill. And if you see here, we are actually discounting, we are reducing the rate of the cost of the debt by the proportion on taxes. Well, the reason is because your interest rate is going to be a deduction on the tax, and that reduction on the tax will actually increase your cash flow. In the practice, when you have taxes and cost of debt, you need to do this to take into consideration the tax that you are actually adding up in the cash flow. And you don't see the tax in the cash flow just as clearly because, and if you remember, there is not a line for taxes inside the cash flow. It's just like operating activities, and you take the net income. And the net income already has the effect of the tax in there. I mean, yes, the paid tax, but also the tax deducted with the interest rate. So when we do this, when we apply something called tax shield, what you are actually doing is you are recognizing that element of tax deduction inside the interest rate. And we need to do that because if we didn't do that, then you will be deducting the whole interest rate complete, and you would actually be deducting the tax twice. I mean, the proportion of the tax related with the interest will be being deducted twice. So that's why we need to do that. Anyway, don't worry, because we don't have interest rates here, so you don't need to do that inside the case scenario. Or in case you see it forward, I mean, other classes, or you need to answer it for the exam, do remember that the formula involves a tax shield. It's pretty straightforward calculation. And here is an example. if you see the formula, this is just to get the proportion out of the complete and entire capital and debt, I mean financing structure, I'm sorry, of the company. Because if you go here, debt and equity, well, you can remember that these two actually come from the balance sheet. And in the balance sheet, you have assets, all right? And then you have something to pay for the assets, and that is the financing activities, and you have debt or liabilities, and then you have equity. Now, why we don't have the word liability here? Well, because in this average cost of capital, you are not supposed to put all the liabilities, because in accounting terms, you may have some liabilities that are actually not generating an interest. For example, vendors, and that is the money that you owe to vendors, and that is not generating an interest. Even though you are financing with the vendors, you are not generating an interest with that account. Another one will be maybe also notes, credit notes for employees. That is money that employees owe you and you will be collecting. But you don't necessarily put a rate onto that. So, I mean that you owe, I'm sorry, to someone. And because if employees were owing you money, that would be an asset. I'm sorry, I just got mixed up. That is notes. What I mean with notes, that money that you owe to someone, maybe you are not paying an asset with interest rate with that. An example of that would be maybe the company owes money to one of the investors, one of the owners of the company. That can happen. So that's how it is. Anyway, the thing is that you take the amount of debt and the amount of equity. All right. In this case, it's 100 and 200, and then you know that the addition of these two is 300. So like that, it was okay. The addition of these two is 300, and you have 100 here and 200 here. So how do I convert this into a percentage to do a weighted average? Well, I know that this one is the total, so I just need to divide them, right? And this will give me this one and this one. Okay, so this will be 33%, and this one will be 67%. The addition of these two will be 100%. Okay, so that way we are here, we are killing this part of the formula. All right, now we have these two numbers. Next is we need to multiply by the rates. You see the cost of equity and the cost of debt, and the cost of debt again should be discounted, should be reduced by the tax shield. So we have the rate of the debt and the rate of the equity. And first I just, well, not first, this is like here, and this is a multiplication, all right? And this is what you get. You get 3% here and you get 23% here. Why? Well, because you are more financed by equity than debt. So the discount rate, or your weighted average cost of capital, your cost of capital total for the financing activities, it's more inclined to the equity side of your balance sheet than to the liability side of your balance sheet. That means that you are financing your activities more with money coming from investors, that is coming from the banks and general market loans. So you just multiply those two, and then you get that addition. Now we had this example last session, and it gave us like 8% or something, and that was an incorrect answer. I was checking that, and I realized that the multiplication we were doing here were incorrect. I don't know why. But we did that wrong. So I have the answer here. We will review it now again. And well, you have 100,000 pesos and 600,000 pesos for financing, and you have weighted debt and weighted equity, right? So again, you just add these two and you have 700,000. The division between this one and this one and this one and this one is this answer, all right? It's this percentage here. And then the multiplication of this times the rates is gonna give you these numbers here. Remember, for the cost of debt, this number, this 9.10%, it actually comes with it comes from the 13% you have here, right? But it actually has to be deducted by the tax shield. So we need to put that here, and you can see here that the tax rate is 30%. That's actually here, right over here. And I'm just saying 100% minus 30% is, well, this is actually 70%. That means that the actual impact on your cash flow is 70% of the rate. Why? Because the remaining 30% was actually deducted from the tax, and it created a positive tax cash flow inside the positive cash flow inside the operating activities as an effect on the net income. And you don't see it as an account in the cash flow. If you go up, you can see the tax deduction inside the income statement, and that's the impact that you are trying to replicate here in the formula. So anyway, we just do that multiplication, you get 9.10%. Now these two, this time this one, and this time this one, gives you these two weighted average, and the addition of these two is 4.73%. And this is annual, and then I just de-annualize it and turn it into monthly. And for this, the formula is you need to take the annual rate, and then you need you need to divide it by the capitalization period. So this is not a mathematical and financial mathematics course. So I'm not going to show you that. But the thing is that you cannot just divide this by 12 and then have this amount. You need to use it as a rate, and then divide it in the months using something called capitalization in the rates. But anyway, well, I put this here in case you have a question of how to convert this one to this one. Well, you need to de-analyze it. But anyway, that's the way you got to here. I mean, this amount is not necessary for us, but this one is important. This is how you get to the WACC. All right, it's just a weighted average, pretty simple, straightforward multiplication and prorrateo in Spanish. So that's how you get it. The last session we were reviewing and it was wrong, so that's why I wanted to review it again. So do you guys have any question about the weighted average cost of capital? Okay. No.
Sure, just
one.
Yeah. How do you get the 9.10%?
You multiply the 13% interest rate, which is this one. You see it here. This one is the interest rate. And I'm gonna erase this because I think it's going to the way. And then you multiply it by the deduction on taxes, which is 100% minus 30%. Why? Well, 30% is the tax. 100% will be the complete interest rate payment. But you don't pay the complete interest rate. You do pay the complete interest rate, but the government gives you back the difference on the tax. There is not a tax course, so I'm not gonna. It will be a little bit more complex to see it on the income statement. Just believe me, it is there. It's in the income statement when you deduct, when you actually deduct the interest out of your tax bill, then you are actually paying less interest because the government gives you the difference. So that's what you are trying to replicate here.
It's like if the government is giving you some kind of support if you're having debts. So that is why it's called the tax shield. Okay, so you're having a discount. In one hand, you are spending on interest, but your actual spending is not as high as you may think, because in the other hand, government is giving you a discount. And that is why we include that tax shield.
Mm-hmm. And as this is going to be a discount rate, thank you, Felipe, which means that you are going to apply to your cash flow. If you didn't do this, then you will be deducting the tax twice, because you will be putting again the discount on the interest inside the cash flows when you already deducted it on the net income. So that's why we need to add. Anyway, you have that, the tax shield, you multiply these two rate, and then you have the 9.10%.
Okay.
Okay. So I think that is clear. Thank you, everyone. That's when we actually left off the previous class. Let's continue now with the course. So the next part, well, while we were reviewing WACC, well, because we need to review net present value. That's actually the topic we were reviewing, net present value, and we needed to calculate the WACC. And I have this little analysis here. I don't know if, I don't think last session we actually did any. No, we didn't. This is the first exercise on what on net present value. So let's solve this one together. How net present value works? Well, remember the thing here is that if you were to add these cash flows into a single line and say, okay, if I were to invest 150,000 on a vending machine and I were to get this every year, then you may actually think, well, this is actually a good investment, kind of a good investment. I mean, if you add this all this up, what you get? If you were to add all those up, well, it will be 50, 1, 2, 3, 25, 1, 2, 3, 6, 1, 2, 3, 15,000, 1, 2, 3, 20,000, 1, 2, 3, and then 100,000. So if you were just to be doing like, I mean, you just don't know about the time value of money, and you just go ahead and just add up all the cash flow, and then you say, okay, and I just need to invest 150,000 pesos, you know, and then you go, well, it's actually it's greater, right? I mean, if I just add these two, I mean, this will be the investment, and we can call this return. You may actually think, well, this is actually a really good investment. I get back my money. I get back 150,000, and I actually win 100 I win 34,000 pesos. So it seems like a good investment, right? I mean, it actually seems like if I put my money in this example, I will actually make a profit. And this it's actually a case that I got asked. It's a real case in Ireland Life. Someone came to me and told me, well, I have the opportunity of buying a vending machine, all right? And someone is lending me the money. This person is gonna charge me 10% interest. That will be my WACC. It's 100% debt, so it's just a straight 10%. And he's telling me that these are the cash flows that I can generate. You know, actually he only had, I think, this one, and we just work down the other cash flows. And he told me, and I can go back and sell the machine at 100,000 at year number 6. So he said he just add up all the money, and he told me, well, if I were to do that, then I can do 30,000 pesos. And yes, it's 6 years. Well, I don't need to do anything. I just need to be changing the machine, and I get a 23%. What is a 23% rate, right? And if I divide that between this was a long time ago, guys, so that's why it's low. I get 4%, so it's a little bit more than inflation. So I actually get my money back. I save my money, you know. I shield it against inflation. He was thinking like that. And what I want you guys to tell me is that if this line of thinking it's actually correct. If I were to just add all this up and just subtract the investment I did at the first period and divide this by 12, am I getting actually the right way? Okay, Anatoly. So if I were to do this, am I actually doing the right analysis? Just adding up the money at nominal value and saying that I'm earning more just by the share difference between the investment. Am I doing a right analysis, guys?
No.
Understand from where you got the 4.
What?
The 4 that you had.
Mm-hmm.
I don't understand from where you got it.
Well, I just got the difference between these two. Then I divide these two together. Why? Because it's the percentage of increase I will have over 150,000. I just divide it by 6 years. Why 6 years? Because it's a 6-year period. I just did that. It's just like, what would you do? What would you do if you didn't know about evaluating investment opportunities? Well, you might actually do that, what I'm doing here, which is what this person did. And he said, well, I have a small return, but inflation is about 3%, so I can shield my money against inflation, and I have an asset to sell at the end of the period of the project. And my question for you guys, I mean, did you get where I got that money out? I don't know who asked because I didn't have my things.
From the cash flows?
Yes, well, someone asked me where did I get the 4% out, and I just explained it, but I don't know if that was clear.
Yeah, well, I got it.
You got it? Okay. So what I was asking is, if I were to do that analysis, do you guys think that analysis will be correct? And then I go with this person and tell him, you know what? It's a good investment opportunity. It's not that much of a return where you actually shield your money against inflation. What you guys think? Will I be doing actually that correctly? Well, the answer is you wouldn't, teacher. Why? Because there is something called time value of money. Money loses its purchasing power during time. And it's more, I mean, it's directly affected by inflation, yes, but when you have something like WACC, that is cost of capital, then money loses its value faster because you need to pay for that money, all right? So let's check that. So that analysis I did here, that is rubbish. I mean, you wouldn't do this. If you were to do this as just to help someone, you are actually, you will be doing him or her harm, because that's not how you analyze an investment project. That is not correct. So what we need to do? Well, you need to apply a discount rate, which will be this one, and we already know where WACC comes from. And you need to put all these numbers in the same, you need to put all the cash flow at the same period of time and then analyze like that. So what you need to do is to discount them. And you remember I told you, right? The compound interest rate is present. I mean, the future value of cash flows is present value times 1 plus the rate and power to the period, all right? So if I were to want this number compounded 1, 2, 3, 4, 5, for 5 periods, I will need to put future value. I just need to plug into the formula. Future value of 50,000 will be 50,000 times 1 plus the rate, which is actually 10%. At what? At the period of capitalization will be 5. And this one will give me the future value of the money, right? Now, what I want is actually the present value of this 50,000 at period number 0, which is when I am doing the investment. Okay, so if you see these jumps here, you can actually see that here, from here to here, I have one jump. Okay, so this will be one period of compound interest. So this 50,000 actually is the result of some present value times 1 plus 10% compound one time. All right, so if this one is actually the result, it means that these other values are also the result on one of a compound interest exercise. So what I need to do is actually do some basic algebra here, and just go and take the 50,000 divided 1 plus 10%, you know, and get the present value. And I need to do that for each of the cash flow for the 6 periods. Why? Because I need the present value at this period to analyze all the cash flows and analyze them at the correct actual dollars, actual pesos, right? Not the nominal pesos. So we're gonna erase this because I have the values here. Okay. So we have first, of course, the initial investment, which is 150,000, and then you have the discounted rates, okay? And the discounted rates, okay, this is the 50,000 divided by 1 plus 10%. Why 10%? Because this one is WACC, it's this one here at the 1. And then you have the second one, which will be 25,000 divided by 1 plus 10% at the 2, and this one here, right? And then you have this one, which will be 6,000 divided by 1 plus the WACC compounded at period number 3. And then you have 12,000, which is actually 18,000. All right, which is discounted at the WACC, cost of capital, at period 1, 2, 3, period number 4. And then you have period number 5, which is this one here. It's 20,000 at 1 plus 10%, 5. And finally, you have the 100. 10%, 6. And what this actually means is that if you were to invest money or just to compound some money at here at period number 0, and then you were to wait 6 years, you will end up with 10,000 or 100,000 pesos at a compound interest rate of 10%. So what we are doing here is we are taking these future values and we are bringing them into the future with hopes of analyzing all the flow, all the cash flow of interest, all the cash flow of interest here at the same period. So you are actually comparing apples with apples. So that's what we are trying to do. And then the net present value will be just the addition of all the discounted cash flows and minus the initial investment, because right now you are actually analyzing all the money at the same time. And my question for you would be here: will you accept or reject this investment project, seeing all the money now at the same period of time and discounting the time value of money effect on the cash flows? Will you accept or will you reject this investment project?
Teacher, I have a real question. Well, see, reject, but because you're going to still lose money, right?
You're going to what?
Still lose money.
Still?
Well, you're gonna lose money.
Yeah, okay, yes, we are going to lose money at the net present value. Exactly, you are correct. We are going if you were to invest the money at this rate, and you will need to do, if you happen to do this investment 150,000 and just wait for this cash flow at 10% cost of capital, you were actually losing money. Yeah, so that is why you will reject this project. And the acceptance rule for net present value is, I want to put the eraser, I don't know why. Okay, so the acceptance rule for net present value is when the net present value of the project, the discount cash flows of the project are greater than 0, then you accept the project. If the present values of the cash flow are lower than 0, smaller than 0, then you reject the project. So the acceptance rule here, it doesn't apply, I'm sorry, because it is lower than zero, so we will reject the project. Okay, so the main thing I want you guys to take out of this is that net present value is the discounted cash flows added all with the investment at the period 0, I mean at the beginning of the project. Okay, so that's what net present value is, and I just show you the formulas and how you have to be adding up each flow of cash at the beginning of the period discounted by the WACC. And if you were to do this each time you do a net present value analysis, it actually will be a little bit hard, because imagine that you have 100 periods, or maybe you, in your case, that you need to do it for 2 months, I mean for like 2 years almost, which is like 20 something periods. If you were to discount each period like by hand, just by applying the formula to each cash flow, it will actually be a little bit hard. I mean, it will be difficult, right, to do it just manually. So Excel actually has the formula for net present value, and you will get the same amount. Actually, if you are following me on Excel, try and do that. Just put these values inside the Excel spreadsheet, and then you are going to use this formula. And the formula in English is net present value. If you have it in Spanish, it's VPN, valor presente neto, and it's just the same. You just take, first you add the rate, and the rate here is 10%. You put it in, you plug it in the formula, and then you select all the cash flows from the first cash flow to the last cash flow, and you close parentheses, and then you add up. I mean, you deduct. I mean, I have it here in negative. That's why I'm adding it up. Or if you were to happen to have this in positive number, then you will have here a minus sign. Whereas I have it negative here, I just add it up. And that's how you get this number here, okay? And Excel will just apply the discount rate to all the cash flows, and then will automatically subtract the initial investment, and you will get the net present value of the project. Okay, that's how you do it in Excel. It's pretty easy, actually. Don't worry. So let's do an exercise. Again, let's do our famous exercises of breakout rooms for you guys to practice. Okay, so it's gonna be a 20 minutes activity. I want you guys to write down these numbers. That's an investment to buy and operate an Airbnb. Okay, so you see the opportunity of leasing an apartment, a small apartment, and buying certain stuff for the apartment, and you get some investment from savings you have, and maybe you get also a credit to invest in the project. And this is actually something that I see a lot. And you get these values of cash flow. Okay, you start year 1, year 2. Here you have a pandemic, and then again the next year, then the next periods you bounce back up, and these are years. So the monthly rents of the Airbnb will be just analyzed in these periods. But anyway, what I need you guys to do is to tell me what is the net present value of these cash flows. Okay. Use Excel for you guys to actually do it fast. So we're gonna do use 3 breakout rooms because I think I was.
Okay, could you share your screen again to take notes of the problem, please?
Yes. Yes, yes. Okay, you all got it?
Yes, thank you.
No, teacher, me no.
Okay, so please let me know when you are finished writing that in your Excel spreadsheet. Now?
Yes.
Okay.
Hola, Chris.
Hola. Hola, Felipe.
Bueno, pues me voy preparando para mi siguiente clase.
Ok, Felipe, nos vemos.
Muchachos. Ándale, ¿todo en orden?
Sí, creo que sí.
Perfecto, muy bien. Sale, nos
Bye.
vemos. Bye. Ahí seguimos en contacto.
Sí. So who is sharing the screen in this breakout room?
I am, but you have to like make me a co-host.
In the breakout room?
Yeah.
Are you sure?
Yeah. When I want to share, it just appears. El anfitrión inhabilitó la función de compartir pantallas.
Maybe just change. Because I cannot do that in the breakout rooms. Wait, let me go to the other breakout rooms to see if they have the same problem.
Okay.
Let me guess, you cannot share screens? Hello?
I don't know.
Yes, teacher, you can.
You can't. You cannot share screens, right?
We haven't tried, but let me see. No, I can't.
You can't, okay. So let's go back to the main session, please.
Teacher, your microphone is off.
Thank you, Andres. So apparently I started the class without without enabling you guys to share your screen, so we cannot do the breakout rooms things, because if I were to, for me to allow all of you to share your screens in the breakout rooms, I will have to end the class and then we all have to go back in again, and just will be a mess. So we're just gonna be doing the exercises in the main room. So the net present value for this will be 435,000. And my question for you guys will be, would you accept or reject this project? Well, if we remember, our acceptance rule will be, if the net present value is bigger than 0, then you accept. Right, so here the net present value is bigger than 0, so we will be accepting the project. This investment will be a good investment, even though you have this sudden drop on income in the period on cash flow. I'm sorry, on period number 3. How did I get to that number? Well, I just applied the formula for net present value, which is this one here. It's just net present value. I use the rate, the 16% rate. I put it here, and then I selected all the cash flows, and I add up as negative value the investment. Remember, I'm adding it up because I have it here as negative. If you were to have this number as a positive, then you will use a subtraction. That's the only keynote you need to take out of the Excel formula. And that's why I got it. It's actually pretty simple. If you have Excel, you just use the formula, and that's it, okay?
Okay.
Now, again, remember why we are doing this? Well, because the net present value cash flows, what they do when you discount them is that you compare all of them at the same point of time, and you take out the time value of money impact on the flows of money you have in the entire project. So that's why we are discounting them, so we can compare apples to apples, okay? And again, it's a comparison at the same point. That's why we are doing the subtraction at the end. And a positive net present value means the investment is worthwhile because you are actually generating money at the same period of time. And a negative investment, negative net present value will mean that it's not a good investment because money loses its value during the time of the project. And what you are finding out when you see a negative net present value is that the investment is actually losing you money at the same period of time, so you will reject that. And just when it's greater, it means that the money earned on the investment is worth more today than is worth tomorrow. So that's why you invest now. If it is the same, well, if it is the same, it means that you are like an investment break-even point. If net present value it's 0, it means that the cash flows, like the discount cash flows, are equal to the present value cash flows. And what this means is that you are actually at a break-even point. The rate there, it's covering all of your costs. You are neither winning money or losing money. It's just a break-even point. And if it's less than 0, it means that you are losing money and it is a bad investment. But I want you guys to think about this concept here as a break-even point, or in Spanish, punto de equilibrio. It's a break-even point of the investment. And when you have a break-even point in your cash flows, in your discounted cash flows, you're actually using a rate that is known as the internal rate of return. When you have a net present value of 0, you have actually found the rate at where you have a break-even point on your investment. That is, that you will not earn money, you won't earn money, or you will actually not lose money either. So that will be the internal rate of return. And that is actually the next part of the class. The internal rate of return is when the net present value of the cost equals the net present value of the benefits, okay? So that is when the investment equals the net cash flow, the discounted cash flows of the project. If you have a project, and I have here a really, really simple graph, internal rate of return will be the rate at where this point of time it intersects with 0 at the net present value, okay? So this is actually another tool for analysis of projects. You have net present values, but if you are doing an investment, what you want is to know the return on the investment, right? What you want to know is, when you are analyzing investment, like you want to buy a share or you want to invest your money on an ETF, well, what you will actually be looking for is the compound interest, I mean the payments, you know, like the rate that the ETF is going to be generating for you, and you look for the rates. And usually what you do, like the first analysis you do, is that the rates are bigger than the inflation, because inflation is the cost to beat in general investment. But here for projects, what you are looking for is that the interest rate, like the internal rate of return of the project, to be greater than what? Greater than the cost of capital of the project. That is the WACC. Okay. So there are three ways to calculate three general ways to calculate internal rate of return. First off, you have trial and error, because you have to plug in the rate of return inside the formula. What formula? Well, the formula of summarizing n equals 0, and then n, and this will be future values over 1 plus the rate at n. And you have all of that. Well, this was actually will be 1, and then you have 2, 3, 4, 5, and whatever, no? And what you do, the first thing that you can do is that you plug in different rates in here to try and find this equalized to 0, okay? And you will do a lot of algebra to do that. So that's a way to do it. Apparently, that's the way you used to do it before Excel and calculators. And then financial calculators came into place, and you can use a financial calculator to find this. We are not using financial calculators here. So if we are not going to be doing this because it's a lot of work, and we're not going to be doing this because we don't have a financial calculator, well, that only leaves us with that option, one option, and that option is Excel. Okay, so we are going to be using Excel to calculate our internal rate of returns. Yes. So how do we calculate the internal rate of returns? And again, this is a project I'm actually evaluating right now as on my day-to-day business. Frank came to me and he told me that he wants to buy a plot of land here in Querétaro, and he actually managed to secure half of the money with his parents and a 5% interest rate. They are gonna charge him 5% because it's their son, so they're gonna charge him a really low interest rate. And the other half of the money, he's gonna get it out of a bank loan. Okay, he's gonna take a mortgage for the plot of land. And those are 5 million pesos. And what he's going to do with those 5 million pesos, he's going to develop a plot of land. He wants to do 7 different places to lease. You know, I think it's 5 apartments and 2 commercial places. He wants to lease them, and he's telling me that he is prepared to sell the place. I mean, he's going to take money out of the investment as cash flows just to repay the bank loans, and then he's going to take the development land and he's going to sell it in 10 years. That's the project he has, and those are the free cash flows that he is expecting. And you can see that at the beginning of the year, it's a really high payment, because this is where he is going to buy the plot of land, and he's going to just spend some money, you know, in like cementation and all that stuff, preparing the plot of land to construction. Then year number 2 is when he is going to construct the place. He is expecting to use 1,500,000 pesos, and then from period number 2 forward until period number 10, he's gonna be generating cash, and then he expects to sell the developed project at year 10. So the question here is, at these rates and with these cash flows, is this actually a good investment? So we are gonna be analyzing this project, and again, remember, you do need to do something really similar for the problem case scenario for Fernando's beer station case. So just pay attention how we do this, because that's what you need to do, the comparison and everything. Okay, so this is what we have. And the first question is, what we need to do? Well, the first thing you need to do is to get the WACC, all right? That's the first step. We need to calculate the cost of capital. And we know we have a combination of rates. We have an investment that the parents are doing, and they are expecting a 5% rate. Okay, that's a fixed rate the parents are going to be giving him. And then we have a loan here, 9.5%. And we know half the money will come from the investment, and the other half is going to come from the loan from the bank. Okay, so how do we calculate WACC? Well, it's actually pretty simple. We just multiply 50% of 5% and 50% on 9.5%. Okay, the addition of those two will be 7.25%, and this is our WACC. This is our cost of capital that we want to be using as a discount rate to our cash flows. So now that we have our cost of capital, we need to discount the cash flows, okay? So we have the cash flows, these are the cash flows. And first thing we need to do is find the net present value. Now, how are we going to find the net present value? We're going to use Excel. Just plug in the formula here, plug in the values inside the formula, and we have these values. Again, I'm just doing this here, adding this here, and this one is actually this one, okay? And I have a net present value of 2,979 pesos, okay? So in accordance with the acceptance rule, we will actually accept this project, all right? Just with a really simple analysis or a net present value analysis, we can tell this person that it's actually a money generating project. It will generate project with actual current, with actual pesos at period number 0 of the investment. At that WACC, it is a good project, okay? So we will accept the project. But now what happens is this, and now, right now we know we can accept the project because the net present value of the cash flows at period number 0 are actually greater than 0. So you are generating money, right? Now this person tells you, well, I would like to know the rate of return this project has, because if you look at this project from a financial perspective, you will see it as an investment, and investment yield returns. So you need to find the return of this project. That is what we're going to do with the internal rate of return analysis. And again, we're going to use Excel. And it's pretty simple. We already have the present value here, so we don't lose that from mine. And it's really simple, internal rate of return. You just plug in all the values in Excel, and that's it. You don't need to do anything else. Why you have this here guess? Well, we will see it as we move forward. Actually, the guess is the rate you think is gonna be generating the net present value of 0, and you will actually need to put a guess there just in case you have unconventional cash flows and you think you have more than one IRR. So that's not the case here because it is not an unconventional cash flow. I will tell you for moving forward what an unconventional cash flow is. Right now, this is not, so just believe me on that. We are not going to put any guess there. And the question here will be, if you were to use the rate here, generated here, you will get a net present value equal to the investment, okay? And the question here is, will you accept or reject the project at this internal rate of return? What do you guys think? I mean, we are seeing that it's about 16% the internal rate of return here. That is the discounted rate. I mean, that is the rate at which the discounted cash flows at net and the period 0 are actually equal to the investment. So will we accept or reject this project? Well, the acceptance rule here is if the internal rate of return is actually greater than the WACC, the weighted average cost of capital, then we accept the project. In this case, we know that the WACC is 7.25%, and indeed 16% is greater than 7.25, so we will accept this project. Pretty straightforward, actually really easy. If you have Excel, you just bear in mind that this is a rate of yield. The project is yielding us this rate, and we are generating this return on Excel. I mean, we are already generating this return on the cash flows, and you will just use Excel with this formula, IRR, and then you will get it. Okay? Any questions, guys? No? Okay. So I want you to think about something. If you actually were to discount these cash flows with that rate, you will see that this 5 million, for example, here, you are going, when you do that, when in the formula you do when in the formula you plug in the values here, you have future value divided by 1 plus the rate through the period. Okay, in this case, you will have 5 million, I want to put a name just to make it faster, divided by 1 plus a WACC of 7.25%, you know, add the 10, yes. This will be the formula to discount this 5 million, to turn them into money or pesos here at period number 0. And what I want you guys to see here is that you are actually compounding them, decompounding actually, each period until you get to period 0, the 5 million pesos. So what all these jumps here means? Well, it means that if you were to take the different, I mean, you were to take instead of discounting the money, of decompounding the 5 million, you were compounding the money using that interest rate that is going from 0 to the 10, from period number 0 to period number 10. It will actually mean that these 10 millions at net present value will be compound each month, that is reinvested each month at 10%. I'm sorry, that is incorrect. You will be compounding or reinvesting that money at 7.25. I'm sorry, what the hell? You will be compounding that money at 16% interest rate. And here I got it wrong. Here, because we are talking about internal rate of return, you will be actually compounding that at 16%. So if we were to decompound these 5 million pesos for the internal rate of return to get the same value as the investment, we will be using 16% because that is our internal rate of return. So that is, you will be decompounding all these 5 million pesos to period number 0 at 16%. So if you were to take these 5 million pesos at net present value to, again, period number 10, that means that you are compounding each period at 16%. Okay, 16% here, 16% here, and you are compounding that money to period number 10 to actually become 5 million pesos. And if you see here, this means that you are actually reinvesting the money at 16% rate. Okay, so that's something to think about. I mean, you are assuming that you will be able to invest in the project the money at the same rate. And the second thing I want you guys to think about is that all of these are future positive cash flows. I mean, what will happen if in year number 5 we have a pandemic again, and this guy gets all his apartments just all the tenants on the apartment just go away? Well, then maybe here you can have a negative cash flow, right? Maybe here and if the pandemic goes too long, or you have a recession period, maybe you have a positive value here, and then you may have another negative value here. Who knows, right? I mean, what can happen here? It's just like crazy what can happen in the economy right now. So you may actually end up with something that is called unconventional cash flows. That is that you don't have positive cash flows every period of the project. So those are two things to consider, right? One is that we are expecting to reinvest the money when you are decompounding it, reinvesting it at the same rate, that is the internal rate of return each year. I mean, which will means that this project has a fixed return rate, which would be really good if it were the case. And the second thing to take into consideration is that if the project condition of the economy change, then your cash flow will be maybe negative some of the periods, and you will end up with unconventional cash flow. So those are two things to consider. First is that in some cases, the internal rate of return will be, I mean, in some cases of analysis of internal rate of return, the cash flows will actually generate more than one internal rate of return. And that is actually when you have unconventional cash flows. When you have unconventional cash flows, then you have more than one internal rate of return. And we will see it graphically, so you can see why you have more than one. But that's one problem. I mean, if you have more than one internal rate of return, then what internal rate of return are you going to be using as compound interest rate, as yield interest rate for the investment to analyze? Which one? We don't know, right? And the second one is what happens if you have, and the second thing to consider is that you are actually, with the internal rate of return analysis, you are assuming that the reinvestment rate of the cash flows is the same each period. That means that you will always get, in this example, 16% as a return on the investment. That is each year. And we know that the economy can change, and as this is a project, not an investment, this amount, I mean, this rate can change. I mean, maybe we know the internal rate of return expected 16%. What happens if we reinvest the money and we don't get a 16%? I mean, what happens with this analysis then? Maybe we can get a lower interest rate, a lower internal rate of return, and end up with a lower return than the WACC. So maybe we accepted this project, we are knowing that that's what's going to happen. So also take that into consideration. Assuming that the reinvestment of the project is always the same as the internal rate of return, means that you will always get the same rate of yielding each year, even though, taking technical consideration what happens with economies and all of that, that might not be the case, all right? Maybe you are reinvesting a different rate. So those are two big red flags we need to be aware of. So we are going to address them, okay? The first red flag is what happens if we have more than one internal rate of return? Well, then we would only use net present value analysis. We would just go like, listen, man, we cannot use internal rate of return analysis because you have an unconventional cash flows, and we cannot use that. We will use net present value analysis, and we will analyze the project using just that one. And the second is when you want to take out the consideration that you are reinvesting at the same rate each period, what you do is that you consider the reinvestment of the cash flows inside the period at WACC. That is at cost of capital, at your weighted average cost of capital. What you do there is that you say, okay, we are going to discount this money. We want to think that the reinvestment rate is not going to be 16%. That is, the yielding of the project is not going to be the same each period. It's actually going to be the cost of capital or weighted average cost of capital. In this case, 7.25%. So that actually means that you are reinvesting the money. You are considering a reinvestment of the money inside the project with a more conservative approach. Okay, so we're gonna see these two to be more, to explain it more, and then I'm gonna take questions in case you are not completely following me here. We will review with examples, and then we will see questions. Okay, so the first one is, how do we identify when a project has multiple IRRs? Well, when you have multiple IRRs, what you have are well, this actually is incorrect. This is not net present value. This is cash flows. Okay, when you have when you have different IRRs, is when you have unconventional cash flows. And unconventional cash flow means that you have a positive and a negative combination of cash flows inside your project. Okay, that means that the project starts yielding a positive cash flow. Generating a positive cash flow, and then goes to negative, then again positive, and then again negative, and then again positive, and maybe negative again, positive. If you have a combination, it's a mess. Okay, if you were to graph this as with net present values, what you will find is that this will look like this. You will have the values here, all right, and then you have negative values, and then again you will have positive values, and then again you will have negative values, and then again positive values. And if you see here, each time this one crosses to the negative, it means that you have an internal rate of return, because we know that the internal rate of return is when the net present value equals the investment. So you have 1, 2, 3, 4 different internal rate of return in this example. So we are identifying the unconventional cash flows. So we don't even need to graph them. If you see a multiple negative cash flow in the life of the period, then you know you have a multiple internal rate of return scenario. And what you need to do is analyze this as net present value of cash flows. Okay, so that will be addressing the first red flag, which is unconventional cash flows with multiple internal rate of returns. The second is we are assuming that the reinvestment rate inside the project is the same as the internal rate of return. That is 16% in the example. So we don't want to assume that, because that is just a really positive attitude, and we want to take a more conservative approach, more risk-averse approach. So what we are going to do is that we are going to actually analyze the project as a reinvestment of the project at the rate of the weighted average cost of capital. That means that we are going to, first off, we're going to calculate the terminal value of all the cash flow. That is the TV. Terminal value is taking the cash flows and actually taking them to the terminal period. In this case, it's 10, because you have 10 periods. And then that you will discount it to the first period, and the discount rate at which the present value equals the terminal value at 0, that is your modified internal rate of return. What you are actually doing here is that you are reducing the reinvestment rate. at cost of capital, weighted average cost of capital. It's the same formula actually, but you just are taking the amounts at terminal value. And the formula to take the amounts at terminal value is that you will take the cash flow of the period, all right, and you will compound it at the terminal terminal period that you are taking the cash flow. So that will actually means that you are compounding the cash flows at the cost of capital each period. All right, you will compound them from the period you are standing to the final period of the project. You will compound it at the cost of capital. Okay, and when you compound all the cash flows, then you will decompound to find the rate at which the terminal value of the cash flows equals the investment. And that will be a rate lower than the internal rate of return, because you are taking out the consideration that reinvestment of the cash flow can be done at the same internal rate of return. In this case, you are saying, look, for us to get this project, we are going to just consider, we are going to consider the reinvestment rate inside the project is not 16%, it's 7.25%, because 7.25% is our weighted average cost of capital. Okay? So let's see an example of the modified internal rate of return. So first off, you have the cash flows and you have your WACC. And how you do it well, actually, let's just, here what you will be doing is that you need to take this one here to the future, this one here to the future, this one here to the future, okay? So for example, let's take this one and let's take just the formula. And the formula says that we need to take the cash flow, compound it to the period, to the net present value of the period. So that will be, CIF will be 960,000, and I just use K for it to be faster. And we are going to compound it. Compound it to what? Well, to 1 plus the rate. And what is our rate? Well, our rate is 7.25%, okay? So it will be, well, actually, let's do it without percentages so we can 0.725%. And then it says that you need to compound it to the end of the period. So it will be n minus the period. So n is 10 minus the period you are, it's 7, it's 3. Okay, so this one should be 160,000, 1.5 to the 7. Why 7? Because you are compounding 1, 2, 3, 4, 5, 6, 7 periods. Okay, that's why 7. And this will actually give you an amount that will be here. I don't know what this result is. But this amount will be here, you know, and then you will need to calculate all the other amounts, a net present, a future terminal value, and then all these, decompound them to the net present value, and then turn them into 0 and find the rate at which those terminal values are the same as the investment, which is this one. And you can see the mathematics will be a pain, because you will need to compound all the cash flows and then decompound, plugging in different rates to find the rate that actually equals to 0, to find the modified internal rate of return. So I think it was Control 10. Okay, so if you were to do that, it would be really hard, right? I mean, you would just have to compound all the cash flows and then decompound them and then just plug different values until we find the internal rate of return at which the values equal the investment. So we don't need to do that, because actually we have Excel, and Excel has a formula of modified internal rate of return is MIR, modified internal rate of return. And the formula is actually you just need to put the values inside, and the values, whoa. And the values will be just take all the, I'm gonna take this, and I'm gonna turn it into a pen because, okay. So the formula is just take all the cash flows, including the investment. This is really similar to the internal rate of return formula. The difference here is that you are going to actually put the finance rate and the reinvestment rate, which is the same because it's the WACC. It's this one here. So what you are telling Excel is, listen, Excel, I I want you to calculate the internal rate of return. I want you to modify as if I were to reinvest the money with a final rate of the 7.25%. That is, I want you to compound all these cash flows to the future, to the last period, and then decompound them until you find the rate at which the cash flows equals the same value at the beginning of the period, okay, which is 3 million pesos, 3,500,000 pesos. I did that, and the result is 12.47%. So our acceptance rule again is the same as internal rate of return, but this time it's with a lower rate. And if modified rate of return is greater than WACC, then you accept the project. So this project actually seems acceptable, even with this modified rate of return. Okay, because it's greater than the WACC. So do you guys have any questions until now?
No.
No? Okay, perfect. This is what you need to do for the homework, by the way. So it's really important for you guys to have it really clear, or you will get it wrong. Okay, so that will be the modified internal rate of return. Now, we are just seeing one project, and if you remember in the case, and actually in life, more often than not, what you have are different options of investment, and you need to analyze project among each other. I mean, you need to compare the projects, you need to take into consideration opportunity cost, and maybe say, okay, this is a good project because this rate is this, and this rate is this, and whatever, right? So if you need to analyze a project, comparing it with another project, what options of analysis you have? Well, you can actually use the same analysis, but you need to use them as comparison, okay? And that comparison rate it's called incremental rates, okay? So why you have to mutually exclusive projects? So now think about your life, okay? Think about your life. Think that you want to start a business. I mean, this is a project that is actually I'm analyzing, and it's a project that you guys can do. I mean, 5 million pesos. If you actually put your money into it, you can get financing for a project that size, and it's a good project. I mean, it's a good investment project, okay? So if you are looking to invest that amount of money into a project, maybe you also want to see other options if you are able to get that money to invest in a big project, all right? Maybe you say, well, 5 million pesos to invest in a building, and then I have to build the building, and I have to just manage the lease, and it's a pain, right? I don't want to do that. Maybe you just go and say, okay, what I can do is that instead of investing in that project, maybe I can go out and find an ETF that pays me a rate greater than 12%, right? Maybe I can go out and find an ETF. You guys know what ETFs are, by the way?
No.
ETFs are tradable funds, are exchange tradable funds. That is, those are investment vehicles that you can find in the stock market, and you can put money into them, and they actually replicate index or some, they either replicate index or some commodity or some business. For example, here in Mexico, really famous and huge ETFs in the financial market are FIBRAs. You guys know what FIBRAs are?
The real estate market.
In real estate fideicomisos, real estate funds. The FIBRAs are huge ETFs that have a lot of money, and what they do is they just buy commercial or residential lots to lease. For example, you guys know where La Victoria is, Plaza La Victoria?
Yes, teacher.
Well, if you were into finance, when that plaza was being built, you will know that the person that built that mall is or was this woman. It's called what? Aramburu Zavala. It was the former owner of Modelo. She has this developing company that is called Ambia, and they developed like half of the Victoria, and then when they will use like 65% to finish, Fibra, I think was Fibra number 2, came and bought the mall. So La Victoria is actually owned by one Fibra, by an ETF on the commercial, by an ETF that here in Mexico invest on real estates. So that's what ETFs are. ETFs are a vehicle for investment that you can actually invest on. There are some really interesting ETFs. For example, there is one that is called SP, and that ETFs follows the Standard & Poor's, and it replicates with different investment on different shares the movement the Standard & Poor's has in points. So that's what ETFs are. They are investment vehicles. So you may be wondering, well, if I have million pesos, why would I go and invest them in a project where I need to develop a land? I mean, I need to develop a building. I need to get all the permissions in line. I need to deal with people, you know. I need to deal with people like I need to deal with the bricklayers, and I need to deal with the architects, and I need to deal with the government. I mean, it's a lot of work, man. I just don't want to do that. I just want like an easy investment. You want to lay back and just do an investment. So you go on and then you look for ETFs, and you find an ETF that actually yields you the 13.08% a year. This ETF, it's actually the SP ETF. It's the rate that historically ETF on the Standard & Poor's it's yielding. So you go and say, okay, if I were to put 1,500,000 pesos, I mean a lot less money inside this ETF, I will actually get a slightly greater internal rate of return. I mean, I'm sorry, a slightly greater modified internal rate of return, and it actually seems like a good investment, right? I mean, I just need 1,500,000 pesos, and I know I can get that from my parents because they are going to. I mean, this investment is 5 million pesos, right? This is 5 million, and I know my parents can give me 2.5 million at 5% interest rate. So, well, maybe I just get less. I mean, I just get 1 million less, and I go and I buy an ETF, and I pay my parents the 5%, and I get the spread I get the spread as income for me, as cash flow for me, and I don't have to deal with all the problems inside the project number, inside the option A as a project, right? What do you guys think? Think. Which option would you guys take? Option A or option B? Who knows, right?
Maybe
option A.
Why option A?
Well, because I believe that in the long term you will have more cash flow.
That's a really good analysis, Andres. Well, Andres says, I will take option A because I have more money. It's a no-brainer, right? And maybe some of you can say, well, yeah, but in option B, I don't have to work. I just put the money inside the ETF. I just lay back, do whatever I need to do. Yes, it's less money, but I don't need to work for it. I just invest it on the ETF, and it's a greater rate. I mean, just look at it. This one is greater than this one, right? The 13% is greater than 12%. I mean, it's not much, but apparently I'm investing, I'm getting more money, right? So these are thank you, Andres. These projects are what are known as mutually exclusive projects, because of course, if I invest on option B, I don't have enough money to develop the land. So I cannot invest both in option A and option B. To get this yield, I need to invest at least 1,500,000 pesos on this ETF, and that will actually defund me for option A. So I need a more deep analysis, and what we are going to do here as an analysis is something called incremental rate analysis. That is, we're going to analyze the incremental cash flow between these two projects, and we're going to see if the incremental cash flow is actually worthwhile investing on option A, all right? Because just as Andres put it, in option A, we have more money, a lot more money. So it's like, well, let's see if that investment on option A is actually worthwhile, okay? So the incremental rate of return is for mutually exclusive options. That's the case we have right now. We have two projects, and if we invest in one, we cannot invest in the other. And we are going to analyze the cash flow, and this is really important. To incremental rates to work in the analysis, both options must be acceptable options. That is, net present value should be positive, and rates of return should be greater than WACC, okay? And in this case, we know the WACC is 7.25%, and we know that the both of the net present value are positive values. So they are both acceptable projects. And again, what we are going to be analyzing is the cost of opportunity. That is the difference on cash flows will represent a cost of opportunity for us. And we are going to get the rate of opportunity. We can call it like that, like the rate of the cost of opportunity. That is the incremental rate of the returns. And we are going to accept the higher cash flow only if the internal modify, like incremental modified internal rate of return, because we're going to be using modified rate of returns, it's greater or it equals the WACC. If the modified internal incremental rate of return is less than the WACC, then we are going to go with the lower option, because that means that the cash flow generated by extra by option A rather than option B actually yielding a lower rate than the WACC. Okay, so the rate generated by difference on cash flow, if the rate generated by the difference of cash flow is less than the weighted average cost of capital, it means that the cost of opportunity is actually greater for us when taking the higher option, the higher cash flow option, than taking the lower cash flow option. It means that inside the project, the reinvestment rate is less than the WACC. Okay? Was that clear? Maybe with numbers it will be better, right? So look, we have the two options, option A and option B, and what we want to analyze are the incremental rates. So we just are going to, from the greater cash flow option, we are going to subtract the lower cash flow option, okay? So because we are analyzing if the option A is better than the option B as an incremental, because we know that this number is greater, right? So we're just gonna subtract this from this and this number, and subtract this from this and this number. And then subtract this one from this one and this number here, and you go on, okay? This means that if you were to invest in another project with the same characteristics as project number, as project A, I'm sorry, as incrementals, then you will get these cash flows. That means, like without technicisms apart, it means that if you invest in project B, and if you were able to invest in project A, the different cash flows you generate will give you a rate, okay? Will give you a different internal rate of return, and that rate of return of the project will be the cost opportunity missed. I mean, will be the opportunity cost missed if you don't invest in project A, okay? And actually what we are seeing here is that the incremental modified internal rate of return is greater than 7.25%, okay? That means that if you were to invest on this option, you will be losing money as an opportunity cost. Why? Because the incremental rates inside project A, even though the modified internal rate of return as comparison between the project is lower, you know, this one is lower than this one, okay? What this means, this 12 here is telling you is that the rates, like the difference of cash flows that you are not investing here, like these two, to generate these cash flows here as an incremental cash flow, it's a missed opportunity of 12.03%, okay? That actually, I mean, if you were to see like in more practical terms, what this means is that if you were to invest on the ETF, okay, and you have the opportunity to invest on developing that lot of land and then leasing it, if you opt to invest on the ETF, you were actually losing on the incremental cash flows. Even though you have to invest a lot more money, you were losing on the incremental cash flows 12.03% interest, I mean, yielding compound interest rate. So what option will you take? Will you take option A or will you take option B? Knowing now that the incremental cash flows actually yield a greater rate of return than the WACC. We will take option A. Why? Well, because the incremental rates comparison is actually greater than WACC, okay? The opportunity cost rate is greater than WACC. That is incremental rate of return. Do you guys have a question?
No, teacher. No questions.
Okay. So let's see the incremental rate of return in a graph way and this in a graphical way. And what will happen if the condition of WACC change? I mean, we know that 7.25% comes one part from financing and one part from investing, right? What will happen if the WACC were to change? Okay, so these options are net present value. And we know that the rate at 15.16%, this one will be internal rate of return. It's 0. And here, there, you have the other internal rate of return for option B, okay? So we know that this rate will be, these two rates will be the respective internal rate of returns for each project. And what we are doing here is actually analyzing with the WACC, okay? We know this is the WACC, and we know that if we take the net present value of the projects at this rate, you will get this net present value. And we are actually seeing what will happen to the net present value if we were to change the WACC each month or maybe each year, right? Because we know that financing, like cost of capital, actually can change if you come from finance. I mean, if you are financing your project with debt. I mean, maybe we go into a recession and then interest rates just spike and you have to pay a greater interest rate and then your WACC will move. That happened in 1994, so that actually can happen. And then what will happen with the options, okay? Would you still take option A or would you take option B? Well, if you want to do a more close analysis with macroeconomic variables, which this will be, you will take the internal rate of return of the project. This time we're going to use internal rate of returns, okay? Not modify, because what we want to do is to find what is the point of difference, like the point where the two projects cross and where one project starts being better than the other, okay? And the acceptance rule again is the same because we're not changing anything more than just the rates to modify to internal rates of return. And if I were to graph these net present values, you will find a graph like this. So this is option number A, this is an option A, I'm sorry, and option B. You can see that the net present values comparison between the rates, between the projects are different. And all of this here is what you earn extra when you invest on option A. All right, but there is a point here, the crossover rate, you see, at which project B is actually better than project A. You see that? From this point onward, it is actually better for you to have invested in option B than to have invested on option B, on option A, I'm sorry. What is this point? This point is the crossover rate point. And the crossover rate point, well, is the incremental rate of return. It's this one that you already know how to calculate. You just take the difference between the cash flows and you decompound and you find the internal rate of return of the incremental cash flows. And that is your crossover point. And what this is telling you is that for option A to remain acceptable, WACC should remain below your crossover rate. That is 15.49%. Okay, if your WACC were to increase greater than 15.49%, that is most likely your mortgage loan rate were to crazily increase like 30%, which has happened in Mexico. Actually, it has happened in Mexico that mortgage loans that are not fixed rates increase crazy with economic with an unstable economy. It happened in 94. Actually, Mexico happened in, like, from all the 80s in Mexico, rates were just crazy because inflation was crazy. And in the 70s also, when Cantarell was found, also interest rates were crazy because Mexico was just mismanaging its economy. So that can happen. It has happened to our country. It's happening right now to Argentina and Venezuela, actually. Rates are crazy because their economies are really unstable. So it's actually a good analysis when you have a really unstable economy to introduce the incremental rate of return analysis and the crossover point, okay? Okay, so the next part is actually payback, and it's an easy subject, but I don't want to rush it because last time we rushed WACC and we just, because we were going too fast, we just got are incorrect results. So I'm not going to rush the last indicator, which is payback period. We're gonna see payback period on Friday, and it doesn't matter if we don't see payback period now, because your homework is actually only for you guys to calculate WACC, net present value, internal rate of return, and I actually also want to modify internal rate of return. So I'm gonna add that to the rubric. I'm gonna add that you calculate the modified internal rate of return. Okay, and I'm gonna change the delivery date of the homework to Thursday for you guys to actually have time to work on that, change your cash flows, and recalculate your indicators. Okay.
Okay, teacher. Perfect.
Okay, so if you don't have any questions, we will end class here. But I just want you, I want to know if you guys have questions regarding this, because remember, you need to actually do these things for the homework. And again, class will be, I will upload the class to YouTube again, and I will put it on my classes, so you can review the video if you need to. If you also have any questions, just send me an email, and we can. I can answer you through there, okay?
Okay, teacher, thank you.
Okay, so if you don't have any questions, we just leave class here, and I'll see you on Friday.
Okay, perfect, teacher.
Teacher.
Thank you very much.
Bye, guys.